All right, this is section 4.7, solving quadratic equations using the quadratic formula. Okay, we've got two objectives here with this lesson. First objective is to solve a quadratic equation using the quadratic formula. The second objective is to determine the number of solutions by using the discriminant. Okay, and you'll notice as you look here at this first key concept, it goes through and it explains to you what the quadratic formula is. It says to solve the quadratic equation ax squared plus bx plus c equals 0, you use the quadratic formula. Okay, the quadratic formula, how they derive it is they take this equation right here, ax squared plus bx plus c, and they solve for x. They get x by itself. And they come up with the quadratic formula, which is the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay? You can solve any quadratic equation using this formula right here. Okay, so if you have a trinomial that maybe it isn't factorable and it doesn't have an even middle term, it has a number in front of x squared, you can always use the quadratic formula, even if it is factorable, and be able to find the answer. Okay, so we have a tell-all solution to solving a quadratic equation with the quadratic formula. Okay, now I'm going to come back to these parts of the notes, how to solve the quadratic formula. I want to go through this part first, and it's finding the number of solutions using the discriminant. Okay, the discriminant is b squared minus 4ac, right here. This little expression right here. B squared minus 4ac is the discriminant. That's what we call the discriminant. You will substitute a, b, and c into the expression to find the number of possible solutions to the equation. Okay? And there are three different possible solutions. If you take b squared and... Okay, so if you substitute in a, b, and c, and whatever you get out as an answer is bigger than 0, or it's a positive number, then you're going to end up having two real solutions. That means you're going to have two real answers. Okay? If you plug in a, b, and c into the discriminant of b squared minus 4ac, and you come out with it equal to 0, you're going to have one real solution. That means you're going to have one answer. So x might equal 3, x might equal 4, okay, or you might see that twice, x might equal 3 and x might equal 3, so it still counts as only one answer because it's the same number. And then the last one is, if you take b squared minus 4ac and it's less than 0, or it's a negative number, that means you have no real solutions. That means there's no real number answers. Okay, and for right now we're going to say that that's no real solutions. Now we're going to get into that later in later sections and decide what that is. Okay, so let's take a look now and figure out how we're going to find the discriminant. Okay, so let's go back and let's take a look at the steps for solving a quadratic equation with the quadratic formula. Okay, first of all, again, like I said before, you want to make sure that you set your equation equal to 0. Okay, that's a number one key. Once you figure out that, you're going to take your values of a, b, and c and substitute into the discriminant first. Okay. Once that number is figured out, then you're going to put it into the quadratic formula. The reason we do this first is because it's going to make life a little bit easier for us. Okay, so find the discriminant first, substitute that in. If you notice, as you look at the quadratic formula, okay, the discriminant is underneath the square root. Okay, that's where the discriminant is. That's why we figure that out first. When we figure out the discriminant, then we can put it in here. Okay, we can put it in there and then solve from there. It makes it much easier to do. Okay. Once those numbers are substituted in the formula, we just need to simplify. Okay? We're going to leave all of our answers in fractions and not as decimals. All right, so let's take a look. Okay, so as you look here at these four equations, okay, the key thing that I think we all need to remember is standard form of a quadratic. And standard form of a quadratic as you're looking at this, is a x squared plus bx plus c equals 0. That's standard form of a quadratic equation. Okay, and what you're doing now is you're finding, okay, what's the number in front of x squared? That's a. the number in front of x, that's b. And then this constant out here by itself at the end, that's c. And what you're going to do is you're going to substitute those in to the discriminant, which is b squared minus 4 times a times c. So you're going to find those values and substitute. Okay, so using the quadratic formula and using the discriminant are just really substitution. Okay, so the first thing that I would tell you to do as you're looking at these problems is to identify what's a, b, and c. Okay, and as you'll notice in the standard form here, standard form is equal to 0. So you always want to make sure first your equation is equal to 0. Before you do a, b, c, set the equation equal to 0. So as you look at example number 1, you see, first of all, is the equation set equal to 0? And it is. Okay, so I got to identify what's a, what's b, what's c. So in this case, a is going to be 2, b is going to be negative 3, and c is going to be positive 7. Okay, and I'm going to substitute that into this formula, that expression, b squared minus 4 times a times c. So I've got b, which is negative 3 squared minus 4 times a, which is 2, times c, which is negative 3. Okay, negative 3 squared is positive 9. Okay, if I take negative 4 times 2, that's negative 8. Okay, so I'm going to write this as 9 minus 8 times negative 3. Okay, and now if I take negative 8 times negative 3, I get positive 24. So this is 9 plus 24. And 9 plus 24 is 33. Okay? So as you look at that number, is that number bigger than 0, less than 0, or equal to 0? That's what you're asking yourself. And you identify, okay, it's bigger than 0. So this means that there's going to be 2 real solutions. Okay? For 2 real solutions. Okay, so now let's take a look at number 2 now. Okay, so as you look at number 2, you'll notice number 2 is not set equal to 0. So I need to get rid of the 6x and get rid of the 5. I need to move these two guys here over to this side. Okay, so in order to do that, I got to subtract them. So I'd end up with x squared minus 6x minus 5 equals 0. And I identified, what's the number in front of x squared? Well, there isn't one there. So since there isn't one there, a is going to be 1. B is going to be negative 6. And C is going to be negative 5. And again, I'm going to substitute this into this expression, okay, to find the discriminant. So negative 6 squared minus 4 times 1, and C is negative 5. Okay, negative 6 squared is 36. Okay, negative 4 times 1 is negative 4. Negative 4 times negative 5 is positive 20. So I end up with 56. 56 greater than, less than, or equal to 0. It's greater than 0, so I have 2 real solutions. I'm going to have 2 real answers. Okay. Same process on number 3. Number 3, I figure out A is negative 4, B is 20, and C is negative 25. Okay, so I'm going to substitute these guys in. So I've got 20 squared minus 4 times negative 4 times negative 25. Okay, so then as I look at this here, I got 20 squared is 400. And negative 25 times negative 4 is 100. 100 times negative 4 is negative 400. Okay, so 400 minus 400 is 0. So if I have 0, is that less than, greater than, or equal to 0? Well, that's equal to 0. So I'll have 1 real solution. Okay, 1 real solution. All right, again, number 4. Okay, number 4, again, A is 6. It's already equal to 0. B is negative 2. And C is 5. So I've got negative 2 squared minus 4 times 6 times 5. Okay, negative 2 squared is 4. 6 times 5 is 30. Times 4 is negative 120. So if I take 4 minus 120, that's negative 116, which means that is it greater than, less than, or equal to 0? In this case, it's less than 0, so my answer here is no real solution. Okay, so you can use the discriminant to figure out how many answers you have. Okay, use the discriminant to figure out how many answers you have. It's either going to be greater than, less than, or equal to 0. One of those three options. Okay. All right. Now let's take a look now at solving a quadratic equation. Let's take a look here at these examples. Okay. Starting with number 1, first thing we always want to check is the equation set equal to 0, and it is. Okay. So since it is, we're going to identify A is 1, B is 6, and C is 9. Okay, so we've identified A, B, and C. First step that we want to do is use it to find the discriminant. So B squared minus 4AC. Okay, so B is 6, so I've got 6 squared minus 4 times 1 times 9. And I've got 6 squared is 36, minus 9 times 4 times 1 is 36. So the discriminant is going to be 0. Okay? Now, the quadratic formula, x equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, that's the quadratic formula. And what we're going to do now is, instead of having to figure out what plugging it in underneath the square root, we've already done that. So now x is going to equal, the b is 6, so the opposite of b is negative 6, plus or minus the square root of b squared minus 4ac is right over here. We already figured that out to be 0. So the discriminant is going to be 0. We'll put that in there. All divided by 2 times, in this case, a is 1. Okay? So x is going to equal negative 6 plus or minus, the square root of 0 is 0, all divided by 2. Okay, so in this case, x is going to equal negative 6 divided by 2, which is negative 3. Okay, and now, as you go back and you look, if you look at the discriminant was equal to 0. So that tells us how many answers? That tells us that we have one answer, and our one answer is that x equals negative 3. Okay? All right, let's take a look here at our... Okay? As we look at this example here now, example number 2, again, the first thing we want to check to make sure is the equation set equal to 0. Okay, and again, in this case it is. It's equal to 0. So, A is 1, B is 4, and C is negative 3. I want to figure out the discriminant first. Okay, so b squared is 4 squared minus 4 times 1 times negative 3. Okay, 4 squared is 16, and negative 4 times 1 is negative 4, and negative 4 times negative 3 is positive 12, so I end up with 28. Okay, so again, I'm going to substitute in to this formula. Okay, opposite of b is negative 4, plus or minus the square root of the discriminant we found down here again is 28, so it's going to be the square root of 28, all over 2 times 1, which is 2. Okay, now you're going to also have to be able to break down some of these square roots. So what perfect square goes into 28? Well, that happens to be 4 and 7. So this is the square root of 4 times 7, which means that the square root of 4 is 2, square root of 7 stays in. Okay, so this is going to be now negative 4 plus or minus 2 times the square root of 7 all over 2. Okay. And as you look at that, okay, now you're not going to have to reduce that expression anymore. I'm not going to be that particular about it. You could divide each of those 4, 2, and 2 by 2, but I'm not going to look into it that much. I'm just happy enough that you get to that answer. Okay, so you're not going to have to worry too much about reducing that. Okay, let's take a look here at number 3. Number 3. Okay, first question you ask yourself, is this thing set equal to 0? And it's not. So we got to get it equal to 0. So I got to move this 4 over to the other side. Okay, so as I move it, I'm going to end up with 2x squared minus x minus 4, and it's going to equal 0. Okay, so again, as we look at this, now you have that. So now a is 2, b is -1, and c is -4. And now if I put that into the discriminant first, I end up with -1 squared minus 4 times a is 2, c is -4. 1 squared is 1. -4 times 2 is -8. -8 times -4 is positive 32. 32 and 1 is 33. Okay, so I found the part that's underneath the square root. So now x is going to equal the opposite of b, which happens to be the opposite of -1. Okay, plus or minus the square root of 33 divided by 2 times a, which is 2. So the opposite of -1, you notice there are 2 minus signs here. They are going to turn into a positive. So this means it's going to equal 1 plus or minus the square root of 33, all divided by 4. Is there any perfect squares that go into 33? No, there's not. So you're done. Okay, so your answer is, again, in this case, will look like so. Okay, all right, so now let's take a last slide and let's take a look at the last 2 questions. Number 4. 4 is a little bit different. Notice we have parentheses in here. Okay, so again, the first thing I got to do is get a set equal to 0, but I got to take care of these parentheses first. So in order to take care of these parentheses, I'm going to distribute that 2x. So I'm going to end up with 2x squared minus 2x equals 3. And if I subtract 3 to get it equal to 0, I end up with 2x squared minus 2x minus 3 is 0. Okay? So again, once I have that thing equal to 0, I can identify A is 2, B is -2, and C is -3. Okay, so I've identified those 3 terms. Now I can look at using the discriminant here. So I've got the b, which is -2 squared minus 4 times a, which is 2, times c, which is -3. -2 squared is 4. -4 times 2 is 8, times -3 is positive 24. 4 and 24 is 28. That's the discriminant. So now I plug this in to the quadratic formula. The opposite of b, the opposite of -2, plus or minus the square root of the discriminant, which is 28, divided by 2 times 2, which is a is 2. Okay, so again, the opposite of -2 is going to be positive 2. So this is 2 plus or minus the square root of 28 divided by 4. But as you look at this, the square root of 28, there's a perfect square in that guy. Again, 4 times 7. And the square root of 4 becomes 2 square root of 7. So now I can write this as x is going to equal 2 plus or minus 2 times the square root of 7, all divided by 4. And again, I don't expect you to reduce that in these answers. I am perfectly fine with you leaving it just like that right there. Okay? All right, now let's take a look at the last question. Okay, and the reason I have this question on here is for a couple reasons. Number one, it's got some things jumbled around. So, I want to get it equal to 0, so I want to subtract 5. And what I'm going to do here now is I'm going to move. Can I move these guys? Absolutely. I'm going to switch them around. So I would have 9x squared plus 12x minus 5, and it's going to equal 0. Okay, so again, A is going to be 9, B is going to be 12, and C is negative 5. Now you notice we get some larger numbers here, so these are going to be kind of interesting. So 12 squared minus 4 times A times C. Okay, 12 squared is 144. Negative 4 times 9 is negative 36. And negative 36 times negative 5 is positive 180. So 180 plus 144 is 324. That's the discriminant. Okay? So x is going to equal the opposite of b, which is negative 12. Okay? Negative 12 plus or minus the square root of, this case, the discriminant was 324, all divided by 2 times a, which is 9. Okay? So, it's going to equal the opposite of 12 plus or minus. If you were to take a look at your multiplication chart and see if in your diagonal, if there's a 324, you'll notice there is. And 324 is a perfect square. The square root of 324 is 18. All divided by 18. Okay? So again, as you look at this, you're going to have two answers. I'm going to set this up two different ways. Okay? X is going to equal. As a matter of fact, we'll write this in a different color. Two different colors here. So X is going to equal negative 12 plus 18 divided by 18. And x is going to equal negative 12 minus 18 divided by 18. Now notice we don't have any more roots in here, so we do have to simplify this one. Okay, so let's take a look here at this, the one on the left. Negative 12 plus 18 is 6. And 6 divided by 18, if I simplify that, that's 1/3. So I've got one answer right there. Okay. Second answer. Negative 12 minus 18 is negative 30. I'm going to rewrite this so it's a little bit easier to read for you. Negative 30 divided by 18. Okay. And now, what's the number that'll go? What's the biggest number that'll go into 30 and 18? And that happens to be 6. So if I divide these out by both by 6, I end up with negative 5/3. And there's our two answers. Okay, so not every answer is going to have a square root in it. Some of them you're going to have to simplify, and some of them you're going to have to where they're not such nice fractions. Okay? All right, so this concludes section 4.7, solving by using the quadratic formula and dealing with the discriminant.